Hello everyone, today I'm here to conduct our lab experiment 4, which will be our last experiment. It is about hydraulic jumps. The objective of this experiment is to investigate the characteristics of a hydraulic jump produced beneath a sluice gate and to determine the flow patterns.
Now let's talk about a bit from the theory part of this experiment. When water flowing rapidly changes the slower flow, a hydraulic jump occurs. This phenomenon can be seen where water shooting under a sluice gate mixes with a deeper water downstream. It occurs when a depth less than critical changes to a depth which is greater than the critical, and it must be accompanied with energy loss. An angular jump occurs when the change in depth is small, and on the other hand, a direct jump occurs when the change in depth is great. If we consider the forces acting within the fluid on either side of a hydraulic jump, this delta H formula can be driven. As you see in this formula, we have YA, VA, YB, VB. And you can see these notations are also given here in this image. There are some explanations about those notations. For example, delta H is the total head loss across jump. VA is the mean distance mean velocity before hydraulic jump. You see, there is our hydraulic jump, and VA, YA, these are before the hydraulic jump, and YA is the depth of before the hydraulic jump. VB is the velocity after hydraulic jump, and YB is the depth of flow after the hydraulic jump. In this experiment, since our working section is respectively short, we will assume YA will be equal to Y1 and YB will be equal to Y3. You can see them here, Y1 is here and Y3 is here. And our delta H will turn into, when we replace Y1 with YA and Y3 with YB, delta H will become Y3 minus Y1 to the power 3 over 4Y1 and Y3.
Now I'd like to continue with the procedure of the experiment. First of all, I will start setting the YG value as 2 centimeters. Then I will go over there to the end of this water tank. I will set some blocks to create hydraulic jump. Then from the switch button, I will start the device and let water inside this tank. And to get the hydraulic jump, I will change the flow rate of the water till I can get a hydraulic jump. Once I got the hydraulic jump, I will measure Y1 and Y3 values. Then I will start changing YG and the flow rate of the water. Then I will record Y1 and Y3 values according to changing discharge and YG values. Now let's do the experiment, the real experiment. I'm starting the device. From here I can change the discharge if I need it to get a hydraulic jump, but first I want to see if I can get it with this current discharge. You see water is started to fill into this tank. Our sluice gate here. We are expecting to get a hydraulic jump here in this portion after the sluice gate. We need to wait a bit till the water level in this tank reaches its real potential. And as you see, it started to produce a hydraulic jump slowly. Let me show it you this way so that you can see easier. As you see, a hydraulic jump occurred already. And this is our hydraulic jump. Now I can measure Y1 and Y3, and from here YG, which was already set, and I will change this charge. Also I will change YG value, and I will get 5 different measurements for this experiment.